All right, we're still working with inverse trig. This time, we're doing nested inverse trig, but now we got some variables thrown in, so it's a little extra fun. So these problems are really similar to the problems in the other video, where you might have had like the cosecant of arc cosine of 7 over 25. And then you went through and you used that 7 over 25 to make a triangle. Same idea. But now we're just got broken with variables. So let's go ahead and use that arctangent to draw a picture. So we're always starting on the inside. We're using this inverse function here. We're going to draw it. Tangent, remember our SOHCAHTOA, tangent is equal to opposite over adjacent. And with these ones, it's just easiest. Let's just always rock in quadrant 1. So the opposite is x, the adjacent is square root of 2. We don't know the hypotenuse, and we need the hypotenuse in order to solve for the cosecant. Right? So the inside helps us draw the picture. The outside is telling us what we're actually trying to find. So I know 2 sides of the triangle, and I need to know the third. Pythagorean theorem. But now we're going to substitute our a squared and our b squared for x and square root of 2. So I got a squared plus b squared equals c squared. Well, square root of 2 squared is just 2. X squared plus 2 equals c squared. Got to solve for c, and it looks like our hypotenuse equals the square root of x squared plus 2. Now that I know what our hypotenuse is, well, we can solve for cosecant. Cosecant is a reciprocal of sine, which means that it's equal to hypotenuse over opposite. So our hypotenuse, we got the square root of x squared plus 2 over opposite side. Remember, our theta is always at the origin, is x. Final answer. I'm so sorry if you can hear Marley chewing his bone. Anyway, continue. Yeah, that's it. Of course, if the square root was in the denominator, you would need to rationalize it, so watch out. Let's try one more. Looking at this, we always start on the inside. I'm going to start with that arc cosine. I'm going to draw it. Well, cosine we know is equal to adjacent over hypotenuse. But we don't have a fraction, so we got to make sure we put it over 1. Adjacent sine is 3x, hypotenuse is 1. 1, 3x. What we don't know is we don't know this side. I'm going to call it b. Let's do the Pythagorean theorem. A squared is 3x. Yeah. Plus b squared equals c squared. Well, the hypotenuse is 1. All right, this is a mistake I see all the time. Make sure when we're squaring this 3x, the squared goes with both of those. So we'll get 9x squared plus b squared equals 1. Solve for b squared. We got b squared equals, I'm going to do it like this, 1 minus 9x squared. Take the square root. b equals the square root of 1 minus 9x squared. Of course, you can do negative 9x plus 1. Up to you. Then we need to go through and solve. Right? We went through all that work to find that opposite side so that we could solve for sine, because sine is equal to opposite over hypotenuse. Well, our opposite side we just solved for. It's that square root of 1 minus 9x squared. Hypotenuse, 1. Don't need to write it, of course. So 1 minus 9x squared is our answer. All right, these ones really aren't that bad. They just look scarier than they actually are. Go ahead and try number 3.